Hey folks, welcome back. This is Joel. In this series, we are talking about Aruba's SD-Branch solution. Now, we have done quite a lot of videos in the series already. We have brought up the topology, we have brought up the branch gateways, the VPNCs. We have also done the underlay routing, right? We also set up the overlay tunnels. And then we also did a little bit of control policies, right? We also played around with the routing in the last video, right? Just to recap and show you the topology what we have done, let's have a look at that. So let's move on to my screen here. Let's grab my pen. Give me one sec. Okay, so I think I got my pen over here. Perfect. So as you see, this is going to be the branch gateway, and these are the two VPNCs, right? We obviously started with bringing the VPNC up, right? Did the configuration of the VLANs, we did the configuration on the LAN side, the uplinks, right? And we used the zero touch provisioning to bring this guy up, right? After that, we went and brought up the VPNCs, and when we brought up the VPNCs, we again did the similar process, but here we used the static activate method. That is, we bootstrap the configuration. We did not do it via zero touch provisioning, right? And again, we did the configuration on the uplink VLANs. We configured the LAN side as well, which is 001. We did the same thing on the DC2. And after these two components were up, we next went and did the underlay routing. The underlay routing was very important because without the underlay routing, your edge devices which are here will not be able to talk to each other, will not be able to connect to each other, right? So there needs to be reachability, because if you want to ultimately create IPsec tunnels, you need, first of all, you need a reachability between those two endpoints, right, where you want to create the IPsec tunnel. So creating an underlay connectivity was very important, right? So we did that. And then we also did some extra steps here, which is we tagged the interfaces as internet and MPLS. Like this was internet and this was MPLS. Similarly, this was internet and MPLS. Why we did this? Because this information is very much needed for whom? For the tunnel orchestrator, right, which resides on the Aruba Central. So if you see, Aruba Central is in the cloud, right? There are two components here, two important components. One is the tunnel orchestrator and the other one is the route orchestrator, right? So once the underlay was up, what we did was we enabled these two components in the Aruba Central. And by doing this, what did we end up doing? Now that we have connectivity between all the three gateways, the tunnel orchestrator was quick enough to create those IPsec tunnels between the devices via the various transports. Like for example, here, right, over the internet we had two tunnels, and here as well over the MPLS we again had two tunnels, right? So something like this. So like this, right? So there was one and the other one was like this, and those tunnels were actually created by this guy, the tunnel orchestrator, right? Because we had set up the underlay before this. Perfect. So that was tunnel orchestrator. And then what also happens is we also have the route orchestrator, right? So what is the job of the route orchestrator? The route orchestrator again resides here on the Aruba Central, right? So think of it as a BGP route reflector. So what happens, all the edge devices will have control tunnels towards the route orchestrator, right? So all the three guys in this case will have those OAP tunnels. That's the protocol which is used, right? The OAP tunnels will be there, and once you have these tunnels, right, so you can successfully tell that, look, I have brought up the data plane and the control plane in the overlay, correct? Because the data plane is the IPsec tunnels, which we just now spoke of, and the control plane is the OAP tunnels. But then what we did was, we weren't just happy with this. What we did was we started playing around with the overlay, right? So we actually started playing around in the control plane of the overlay. We started taking these subnets, which advertising them in BGP, and from them BGP we redistributed into the overlay. Similarly, on the other side, we had connected routes, we redistributed it into the overlay, right? We also did the reverse. From the overlay, we redistributed it back into BGP, and we did all of that fun stuff in the overlay, because ultimately we wanted connectivity, end-to-end connectivity from the branch to the data centers or the VPNCs via the overlay, right? So all of these routes, they exist in the overlay, right? So that is what we did. So in the last video, what we did was we tinkered with the overlay control plane, right? The plain vanilla control plane is just the OIP tunnels. But once you have the OIP tunnels, what you can do now is you can you can send your routes, right, to the route orchestrator. It's like a BGP route reflector. So these routes are going to go to the route reflector or the route orchestrator, and it is going to reflect those routes to the other sites, right? So that's where you can do some magic. You can define which routes you want to be reflected, which you don't want, and you can establish connectivity with that. So that's what we did in the last video. In this video, what we'll do is we'll play around with the data plane. We know that we already have the data plane, correct? We already have the IPsec tunnels, the 4 tunnels which we just now spoke of. From here, we've got one tunnel to the VPNC, one via the internet. You have the other one over MPLS. Similarly, for the second data center, you have 2 tunnels. So we have 4 tunnels, correct? Now, if you look at from branch perspective, you have 4 tunnels, right? And in that 4 tunnels, 2 are towards VPNC1 and the other 2 are towards VPNC2. Great, we have these tunnels already up because of thanks to tunnel orchestrator. But are we happy with this? No. Now what we want to do is we want to write policies so that we can influence the traffic that is flowing through these tunnels, right? Can we write a policy based routing policy, right? Can we write PBR to kind of maybe use out of these 2 tunnels, right? For VPNC1, can we use can we give high preference to maybe one of the tunnel than the other one? Can we use one uplink? Can we prefer one uplink over the other and things like that? Yes, we can do that. We'll also explore DPS, right? Dynamic path steering policy, which is very similar to application aware routing, which we did in SD-WAN, right? You can define an SLA, and if the SLA is not met on a particular uplink, then the traffic is going to switch to the standby uplink, right? That's what we are going to do. I just wanted to do a 5 minutes recap of whatever we have done, so that this is one of the most important topics. So that's why it's important we kind of know whatever we have done here, right? Coming back to our central, okay, looks like it's logged me out. Let me log in. Okay, so the central is here. Just you can have a look at all my 3 sites, right? Everything looks green, which is fine. Maybe we could also check quickly the gateways. Maybe let's check one of the gateway, maybe the branch gateway, and we can go to the WAN, right? We can go to the tunnels, and there you go, all the 4 tunnels are up, right? So the data plane is good, which is good. Perfect. We can also probably have a look at maybe the tunnels, the control plane as well, right? You can have a look here. You can see the control tunnels are up, which is good for both the hubs as well as for the for the spoke, right? So that's good. You can see all the routes which are getting learned and everything. Great. So basically the the site is up, which is a good thing, right? Now let's start with let's do this step by step, because it's a little bit of an extended process. So what I'm going to do is I'm going to do this step by step, right? Step number 1, what do we do first? So we are going to start with PBR, right? Policy based routing, right? I think I have a diagram here to kind of show you what PBR is. Again, this is from the Aruba's validated guide, which is again available online. I think I will probably paste the link of this in one of the video, in the first video, so you can check. But the whole idea is, policy based routing generally is where you define classification. You create some kind of a match, traffic matching logic, right? And if the traffic is matching your logic, normally traffic is routed using the destination IP address, right? So packet comes into the interface, and the router looks at the gateway looks at the IP address of the destination, destination IP address, and based on that, the lookup is done on the routing table, and the packet is routed out on the outgoing interface. That's how your normal typical routing happens. But in PBR, as you see here, you can do you can match the traffic based on certain criteria, and if the traffic matches, then you can define the next stop, right? So it's slightly going against the normal typical routing concept, right? So that's what we are going to do here. So step number 1 would be, first we'll have to go and create the next stop, which I talked about, right? And we are going to do this on the branch side. So for the branch side, what we are going to do is we are going to categorize, we are going to think of what are the various traffic flows which are possible. Like for example, from the branch side, we can have traffic to the VPNCs, correct? That's one flow of traffic, especially to these subnets which you see here, 10.1.128.129, right? So these 4 subnets. So you can have that as one of the flow. The second flow could be traffic from the branch to any other, any other subnet apart from these 4, right? And the third one would be traffic, between the branch subnets, right? So we are going to kind of categorize, the traffic coming out of branches into those 3 categories, right? And then what we'll do is we will define the next hops for each of the traffic types. That's what we're going to do. So let's do this step by step. Step number 1 would be first creating the next hop. So we'll go to the branch here. Let's go to the branch and click on branch group, click on devices. Let's click on the specific device. We'll do this at the device level, right? And then we will go to again device once again. Let's click on routing, and you see there's a section here called next hop configuration, right? So in the next hop configuration, let's create a name. We could give any name, right? In my case, I'm going to give something like next hop branch dash internet. It can be anything. It's just a logical name for a list of next hops which are going to create, right? So that's the name. I think we will, can we just hit the plus button? I think we can, let's hit the save button, and then subnets is empty. That could result in dropping topic. Please ensure that, okay. So I think we will have to, yeah, I think that's fine. We'll just first create the name. Anyway, we are not adding this PBR. We are not enabling the PBR, so we're not going to be dropping the traffic. That's fine. So we just created the next hop as such, right? Now we can create below, as you see here, right? So these are the sections. So first we can create a IPsec map, right? So we'll have to, when you create a nest hop, in case of Aruba's gateways, you see a next hop can have these let's call them attributes, right? It can have the next hop IP, right? It can have the IPsec map name, right? So that's what we are going to use. We are going to use, when you say IPsec map, it's basically the IPsec tunnel. We are basically selecting which tunnel the traffic is going to use. Gonna hit the plus button, right? And instead of site to site IPsec, let's use the IPsec tunnel to VPNC, right? We are doing this on the branch, and we are going to use the IPsec tunnels towards the VPNC, okay? Then we will use the IPsec tunnel to which VPNC? We'll use the VPNC 1, DC1, perfect. We can, the next is we will have to define which uplink also, right? Now if you think of, again, try to imagine from the branch to DC1, we have 2 IPsec tunnels, right? One is over MPLS, so we're going to add the MPLS guy, right? Click OK, and we will create one more IPsec map for the internet. So we have 2 uplinks, right? And so 2 tunnels, and this is this particular IPsec map is specifically for the tunnel via the MPLS circuit, right? We'll give it a priority as well. So we'll use this priority later, but for now, just add a number of 100, and yeah, I think we are good to click OK, right? So we created one IPsec map. Similarly, let's go and add the second guy, which is going to be again IPsec tunnel to VPNC, right? The device is going to be VPNC1. Uplink is going to be internet this time, right? Because this is categorized, or this is pertaining to the second tunnel, right? Which is why the internet. So I'm going to click OK. Now the priority here, we are going to give 128. We'll give it a higher priority, right? Basically the understanding here is that when this PBR policy is activated, the internet uplink or the IPsec tunnel via the internet is going to be more preferred than the MPLS, right? You see where I'm going with this. We are trying to tinker with the we already have the IPsec tunnels, but we are now trying to prefer one IPsec tunnel over the other, right? Using PBR. That's what we are trying to do. So by looking at this, you can clearly understand what we are trying to do, right? We have preferred one IPsec tunnel over the other guy. Right, perfect. So we're going to hit the save button here. Right, perfect. Okay, perfect. Now the second step is we have created the next hop. The second step is we need to now create what we call as aliases, right? So think of this scenario, right? Let's again go back to the topology here. Think of it, this scenario. Why we are creating this alias is because Right now we have these VLANs, VLAN 567, right? And remember, right now we don't have the second device, right? The BG2 is not yet up. But imagine in future we will have this device up, right? And if both of these devices are in the same group, right, there is a possibility that this particular device might have the same VLAN, which is VLAN 5, 6, 7 and 8, right, just like these VLANs, but this device might be using a different subnet. Totally possible, right? You might not have L2 connectivity like this. It might be a separate branch gateway, right? But it might be part of the same group, right? But it might even be having the same VLANs but different subnets. So what we'll do now is we are going to create a PBR policy where we are going to create aliases for VLANs, right? So that in future, if you add more branch gateways to the same group, right, the PBR policy will still work for that new branch gateway, even though it might be using different subnets for the VLANs. That's the whole point. That's the whole reason we are not going to create our PBR policy dependent on IP subnets, right? We are moving away from IP subnets. We are going to create aliases for the VLANs. So that's going to be the second step. Let's follow through, right? So for that, we will do this at the group level. So let's go back one step. We are in the devices section, and here let's go to config. We should go to the advanced tab, and here we'll go to security, and there is a section called aliases, right? So right now you see these are the aliases which are already there. Different types of aliases, as you see, right? What we'll do is we'll hit the plus button here, and let's create an alias for, let's call this branch advertised subnets, right? So that's the name which we are giving for it. And below, right here in the item section, we are going to add the various, so you can either have the IP, so we are going to make the rule type as what, it's going to be the override, right? So we're going to select override. That's how you define those VLAN aliases, right? So you select override, and here you're going to select VLAN, right? And which are the VLANs? 5, 6, 7, 8. That's on the branch set. So I'm going to create one for 5. Similarly, let's select again the same thing, which is override and VLAN, and for 6. Why we are just doing this, like I mentioned earlier, right? This is just to kind of remove the dependency on IP addresses, to make our PBR policy independent of IP addresses. So this is going to be 7, and the last guy is going to be, let's again select override, VLAN, and the last one is going to be 8. Click OK, right? 5, 6, 7, 8. So those are the 4 VLANs for which we want our PBR policy to be applied, right? So I'm going to hit that and hit the save button. Perfect. So we have gotten the aliases for the source, right? That is, we have gotten the aliases for the PBR policy, for the source of the PBR policy, right? So we can now define a policy telling that local traffic coming from VLAN 567, apply the PBR policy. Now we need to define the destination as well, right? Where is the traffic going from? Where is the traffic going to? We have defined where it is going from, but where is it going to, right? So for that, again, we'll define one more alias, and we are going to call this as corporate subnets. Corporate subnets maybe to the DC1. And which subnet we are going to use? Like I said, we are going to use these 4 subnets: 10.1, 128, 129, 130, 131. Instead of defining it 4 times, what we'll do is we'll create a summarized mask, right? So it will be, because they are all, the subnets are one after the other, it's easier for us to create a summarized mask, correct? So here we'll again add the same thing. We'll click on plus button, right? But this time we will make this IP dependent, right? We'll just use directly network. We'll put the subnet, but instead of putting /24, let's go with a bigger subnet mask. That way, this particular now subnet wildcard mask is enclosing all the 4 subnets which we just now saw. Perfect. There you go. So we have created the source and destination for our PBR, right, to match on. Perfect. So we've got all the components. Now it's time to create the PBR policy. Okay. So for creating the PBR policy, what we need to do is, again, we need to go to the group. So we are already on the group, right? We are on the devices. Let's actually go to the specific device, which is VG Gateway 1 here, right? And I think we'll have to go to device. Under routing, you will see policy based routing. This is the place where you have to do the configuration. We are going to do this at the device level. So policy based routing, we're going to select it. Right now you see there is some policies which are already present. There are no rules under it, but we'll create a new policy over here. We'll give this title, right? We'll call it something like full tunnel, right? So this is basically going to signify, right, all the traffic. When you say full tunnel, it basically means that all the traffic coming from the branch, right, from any of those VLANs 5, 6, 7, 8, those are the client VLANs. So we are basically taking all the traffic. The full tunnel is basically signifying the other counterpart of this is split tunnel, right? So we're not doing any kind of split tunnel here. All the traffic coming from the branch, right, we are sending it on the overlay, which is going to be the IPsec tunnels, right? That's the significance. So I'm gonna click on save. So you just need to give a name for the policy and then start creating the rules under it, right? So that's the policy, and here below you see you have option to create the rules, right? So I've clicked the plus button, and this is going to be my first rule. Okay, the IP is IPv4. Source, we are going to do it based on alias. See, now you see the importance of creating alias. We created alias. Source alias is going to be which one? Branch advertised subnets, correct? And destination is going to be, so now this is where I said what are the various types of traffic. First, let's capture the traffic from branch subnets to the data center 1 subnets, which we just now created, right? So remember, we use these 4 subnets. We did not use 10.1.1. we'll use that for the DPS policy. So we'll use only these 4 subnets. So we will select that guy here. Again, we'll select network, and sorry, I think my bad, not network, we created alias for that, right? So we'll create alias, and here we will have to use the corporate subnets DC1. Perfect. Service and app can be anything, right? You can actually specifically define the application, but we are going to say any, because we want PBR to be applied for any kind of traffic. Now the interesting thing here, right, you have different options. As you see here, you can forward regularly, correct? Or you can define forward regularly means the traffic will just use the, if you look at the table here, or if you look at the diagram here, forward regularly is this one, right? So if the traffic is matching, it will forward regularly. It will just use the routing table to forward it, right? If you really want the PBR to be applied, you need to come here to the next hop, right? So what we are going to do though is traffic from branch to these corporate subnets, we are going to do forward regularly. That is forward like how you would do otherwise, which is use the route table, then use the tunnels, and then send the traffic, right? So that's what we are going to do. We are not going to use the next hops which we created. We will do that for the next traffic flow. For this traffic flow, this is good. So I'm going to hit the save settings. Right. Let's go for the second rule. Right. For the second rule, what we'll do is, again, we will select IPv4 alias. Alias will always, the source will always be the branch subnets. Destination. Now the destination is any. We'll keep it any now. Right. And for this one, we will use the next hop. Remember the next hop which we created. And will we do load balance, or no? We will use this next hop which we created, right? The next hop. As per this next hop, we are using the internet tunnel. We are preferring the internet tunnel over the MPLS tunnel, right? I'll explain this complete rules once again once I finish creating the 3 rules. And the third rule is going to be for traffic originating from the branch and destinating to the branch, right? So that's going to be something like this. IPv4 sources alias, this is going to be branch, right? Destination is also an alias, and this one is going to be also branch, right? And this one also we are going to do forward regularly. Perfect. Now let's quickly have a look at what we created, right? If you look at the policy here, now I think you kind of understand. So what we did was traffic going from the branch subnets, which is 4, 5, 6, 7, 8, to the corporate subnets, those 4 subnets, we will forward it as per the routing table. The next is traffic going from those VLANs 5, 6, 7, 8 to any in the sense maybe using internet, right? If you want to go to internet, maybe you want to ping 8.8.8, then what is going to happen? traffic will go as per the next hop list which we have created, right? Which means it will use internet, it will prefer internet. And for the last one, this is mainly again traffic between VLAN 5 and 6, right? Or 5 and 7, 5 and 8. So traffic from branch going to branch, we are again going to forward it regularly, right? So this is but how you can create a PBR policy, right? So you can match the source, match the destination, and then you can tell what action it has to take. Do you want to forward it based on routing table? Do you want to forward based on the next hop list which you created, and so on? Perfect. So that is good. Now the next important thing we will do is we'll have to apply this policy, right? Now this is where we'll do some interesting things, right? We'll have to get into the concept of roles, right? Now again, for people who are very new to Aruba, you might have not heard of roles. Again, if you're coming from the Cisco's world, the closest thing I can think of is, it's not exactly the same, but its closest is TrustSec, right? Remember we did TrustSec, microsegmentation. So that's something what roles does here in Aruba, right? So role is basically a way of kind of creating tag, I guess, for a particular type of user, and putting all the various policies, security policies for that user, maybe ACLs and all of that, right, for that particular user, right? Remember again in Cisco, if I go back to Cisco, we had the whole, we had those SGTs, and then you had SG-ACLs, right? That the SG-ACLs were independent of SGTs, right? But here, I think the closest I can the analogy which I can think of is, the role and the policies are very tightly coupled. They're configured at the same time, right? Anyway, so why I'm just telling you that is because to apply this PBR policy, what we are trying to do now is we will, we know that we have 4 VLANs, 5, 6, 7, 8, right? So what we will do is we can now apply this policy in a different way, right? You can apply the policy completely to a particular VLAN, or you can also apply the policy per a particular user as well, right? So there are different ways of doing it, right? In fact, I think we will explore a couple of ways of doing it. First, but before anything, we will have to create a role, right? Because let's assume that one of our user, right, who is going to be here on the topology, right, on the wired client, let's say this particular wired client is going to be in VLAN 7, right? So, we will have to give him some role, right, to kind of accept the traffic coming from him, and then we will have to initiate the PBR policy and so on, right? So yeah, just follow through for now, and then when we do a recap, you will understand this in a much better way, right? So let's start with roles. So step number 1 is again this is going to be device level configuration. So I'm already here. Let's go to security, and there are going to be some roles which are default created, right? If I click on one of this role, you can understand what a role is, right? So you can see this is the role, and you can see the various policies which are defined for that particular role, right? I can probably click on this policy, and you can maybe see the access control ACLs which are part of it, right? So you have a role in Aruba. You always have a role, and then there are policies defined on that role. So when a particular user connects, right, to the network, it can be using .1x, it can be using map, right? You can then use your NAC, just like Cisco ICE. Here you can use ClearPass to kind of provide or assign a role for that user, right? And once that role is assigned, the policies of whatever policies are present over here will get activated for that particular user, and that particular user's traffic will comply as per the policies. That's the whole bigger picture of the roles. Okay, coming to roles, let's go and create the new role which we want. We are going to call it employee, right? Going to click on save. Now once we have created the role, what we will do is we'll click on the role. So right now there are no rules for the for the role, right? So what we'll do is so there are a couple of, like, whatever gets created by default, we don't have to worry about this. This is something which gets created by default. That's fine. So anyway, so we are on the policy. Let's click on create a new policy here, right? And add an existing policy. We will select this, right? And the policy type is going to be session, and policy name is going to be allow all, right? So I'm going to hit the save button for this one. So this is how you can create policies. So right now we have just created a role and we are just allowing all the traffic from that role, right? So that is good. Ideally this won't be the case, obviously, when even for an employee you would want to restrict some kind of traffic, right? So you would obviously restrict. In our case this is not of very much importance. We are not running a very, our topology, we are not running a proper campus environment, we just are doing some testing. So just because I need a role, I've just created a role and I've just allowed all the traffic inside that role. Okay, now let's come to, so we have created the role, which is good. Now let's come to yeah, so that's good. So we'll come back here on the left hand side. So we'll come back to the group, right? So okay, so we are on the group, and let's see, should we do this on the group? And yeah, so we can do this on the group because yeah, anyway we just have one device in the group, so technically you can do it on the group or the device level, but anyway let's do it on the group. On the group configuration interface, right? So on the interface, on the port, right, so you have the ports, and if you see gigabit 0/1 is our LAN port, correct? So that's the LAN port. Perfect. So you see this is the LAN port. We have already configured this in the initial video, but there is a very interesting thing here, right? So if you see there's a section called trust, right? So here you go, trust. Right now we have trusted all the traffic, which means the VLAN 5, 6, 7, 8, everything which is coming in is getting trusted, and nothing is getting authenticated. But remember, I told you the logic. What we intend to do now is when the traffic comes in, right, especially from the employee laptop, we want the traffic to be first authenticated, right, and then a particular role has to be assigned. For that process to happen, we need to make sure that this particular interface is untrusted. Only then that will get triggered, the whole role and all of that will get triggered, right? So we'll uncheck it and hit the save button here, which means now all the traffic coming from VLAN 5, 6, 7, 8, when it comes into the branch gateway, it is not going to be blindly accepted. Traffic needs to be authenticated for the traffic to pass through, right? So, and the whole concept of the role and all of that will get triggered. Okay, perfect. So we have done that. Now we will go to security, and there is a section here as well, apply security. And here, remember, on the gigabit 0/ the same interface, if you see here, it is selected as trusted, correct? So we will have to make it untrusted. So we're going to select this guy, and same thing, whatever we did earlier just now, we did it on the interface. Now we are doing it for the VLANs as well, right? So we're going to select that, and we've unchecked it, and basically what we have made is we have made the interface and the VLANs on it as untrusted now. Okay, so this is needed, like I said, this is needed for the whole role and all of that to be triggered. So this is good. So this was mandatory, right? Now next is we will create the AAA profile, right? Whenever we talk about role assignment, we need something called as a AAA profile to be created for the device, right? Just like how we did it in the Cisco's world as well, right? You need a particular role to be, you want .1x to be done, you want map to be done, you have to put the AAA configuration, right? So similarly here for role assignment, you need to do the corresponding AAA related config, and that's what we are going to do. So let's come to, again, this is something which we will do it at the device level, right? So let's go to list, click on the specific device, which is BG Gateway 1, right? And let's go to device again. Let's go to security, right? There should be a section called role assignment here. There you go, AAA profiles, and here you go. This is what we have. There is nothing right now, so I'm going to click on plus, and this is what you get. So these are some of the default .1x, map, and all of these profiles which are already there, right? We will create a new profile, right? Because we are not going to be doing .1x and map and stuff, but we will just define what type of authentication we need here, right? So we are going to create a new profile. So that's why I clicked on plus, and I'm going to click the plus button here, give it a name. I'm going to say employee, right? And again, in case of this role assignment, right, there is it's a very lengthy, very interesting topic. We'll probably discuss it again in future in much more depth, but you can also do things like before authentication, before .1x or map is done, you can assign an initial role, right? And once the authentication is done, then you can assign some other role with better privileges, right? That's how most of the people do. Initially what they do is they'll generally assign a very initial role which will allow only DHCP DNS traffic, right? And then once authentication has gone through, then they assign a much lenient role, right? So we are going to use similar kind of logic here. What we are going to do is, since we are doing testing here, right, all we need to make sure that the employee role is assigned for this particular client, right? So what we will do is we will use the employee role which we just now created. We'll use that as the initial role. That's it, right? We are not worried about .1x and all of that because we are not going to do it, right? We're not going to be doing .1x, and so technically you can do it, but it's of no use for us. All I need when the client comes into the network, I want that client to be assigned the role of employee. That's it. Because at a later stage, what I intend to do is my PBR policy I'm going to trigger based on the role, right? That's the whole reason why I'm doing this. Hit the save button here. Perfect. So that's good. Now, so we have made the VLANs untrusted. We have created the role, right? The last step here needed is we need to, out of the 5, I think we have 5, 6, 7, 8, right? Let's pick one VLAN. Let's maybe pick VLAN 7, right? So let's go to security, apply policy. So we need to apply everything together now. We have created the we have created the role, we have created the AAA profile, right? We need to apply this to a particular VLAN. So that's what we are going to do. So if you see, there is a VLAN here 7, right? So VLAN, and you can see there is a place here for assignment, right? So in the role ACL, route ACL, we're going to apply the full tunnel which we just now created, right? The PBR policy basically, right? So the PBR policy, right? So the PBR policy for VLAN 7, we're applying the PBR policy, and what the role is going to be, the role, this is role assignment, sorry, this is the AAA profile. So this will be the employee wired AAA. Perfect. So that's what we are going to do. I'm going to hit the save button here. Perfect. So this is just one way of doing this. I will obviously be showing one more way of applying the PBR policy, but what we did just now, right, just to recap, right, what we did is we started by creating, let's actually write this down, right, because I think we did a lot, so it's better to kind of review whenever we do things, right? So step number 1, we created the next hops, correct? You agree with me? We did created the next hop, and in the next hop we basically made sure that the internet was preferred, right, over MPLS, right? MPLS, right? So in the next stop we basically created those IPsec maps, and we basically said that, hey, prefer the internet tunnel over the MPLS tunnel going towards the data center one. Then we created those aliases, remember, and I explained why we created aliases, but we created aliases, and we created aliases for the source of the traffic and the destination of the traffic, which is the branch subnets and the DC1 subnets. Then we created the PBR policy, right? That's step number 3, right? The PBR policy was that full tunnel policy, and we segregated 3 separate sections in it, right? We defined what are the 3 possible traffic flows, and we created the PBR policy. Next, step number 4, now we need to apply the PBR policy, right? So for applying the PBR policy, so we have to next apply the PBR policy. Now technically, I mean, this is where the PBR policy is getting applied, right? So on the VLAN 7 we have applied the PBR policy, but we also needed what we call as a AAA profile, right? So when any kind of traffic is coming into the gateway, we need some kind of a role for that particular client. That's the reason we created a role. We allowed all the traffic inside the role. We did not put any policy. We allowed all the traffic inside the role, and then we used that particular role as the initial role in the AAA profile, right? So now when any traffic comes in VLAN 7, right, that particular traffic will be identified with the role of employee, right, on the gateway, and then this particular PBR will get activated. That's the whole funda behind whatever we did. So now this calls for celebration, but also before that we will obviously need to verify and test if our policy is working, right? So fingers crossed, right? Let's see if just delete this. Okay, so we are going to now verify, right? The policy, give me a second. Okay, perfect. So we're going to verify the policy. So for verification, what I have is I have a client here, right, which is the wired client. WLTs, I think it's somewhere over here. This is the client, right? Perfect. So this is the client we have. Right now I have disabled the interface over here, right? So I've disabled the interface, but that's okay. So I will now, if we have everything ready, I think we have everything ready. So I will, because right now it should not have any IP address. So I'm going to do IP config. By the way, I have put this particular client in which VLAN over here, right? I put it in VLAN 7. So I put it already in VLAN 7, right? And this particular client, right? I'm in the clients. Right now you see it doesn't have an IP. I will now enable this. Remember, we have already done the whole DHCP and stuff, right, in the first video. So we have done the DHCP on the branch gateway. So for VLAN 7, traffic is going to come to branch gateway, and from there branch gateway it is going to assign IP addresses and all of that fun stuff, right? That stuff we have done. So there you go. See, the interface is up. Let's see if it has received an IP address now. Looks like it has. Look, at the IP address is 10.107.129. Let's try to ping the default gateway which is visible here. Ping 10.100.7.1. Perfect. Looks good. So we have connectivity as well. Now for testing, right? So we will have to so we basically need to make sure that we send some traffic, right, from this client. Now let's look at our PBR policy. Actually, let's come back here. So where is our PBR policy? The full tunnel policy, right, which should be here. Okay, let me just find that, right? So it should be somewhere here. So this is the PBR policy, tunnel, full tunnel, and there you go. So where are the rules? Okay, there you go. The rules are showing. Sometimes Central takes a bit of time to show things. So let's click on it. There you go. So these are the rules, right? So what we'll do now is, for this next hop to be triggered, what we need to do, we need to send the traffic from the client, but we shouldn't send it to this corporate subnets. We should send it to this any, right? Which means we can ping say 8.8.8. We can do that, right? So we can ping 8.8.8. So let's see that. So let's do a maybe continuous ping, right? Let's do maybe like continuous 10,000 ping, right? So there you go. The ping is coming in, continuous ping is happening, which means traffic is getting generated. So we can now go to our branch gateway, right? And from the CLI, let's try to verify some things. So we are on the branch gateway, right? So let's look at show user. Okay, there is nothing yet. We will have to wait. Okay, so looks like I'm still not getting it, and I think the reason could be, I remember seeing this issue once in the past, right? The reason is probably because we have maybe trusted the VLANs, right, on the device level. We did the configuration on the group level, so that's another thing which happens a lot. So we can go to the device level now and verify. So let's go to device and let's go to interface, right? And over here under the ports, you can see this interface, and you can see here looks like it is trusted. So I'm going to uncheck it, hit the save button. Okay, so let's wait for that. I mean, the reason is because whatever configuration you do at the group level, and if you do the similar configuration at the device level will take precedence, right? Let's check the security as well. When you look at apply policy, and if you select this interface, looks like it is still trusted. So I'm going to uncheck it. So remember, these two steps we did, but we did it at the group level. But at the device level, looks like we had done it previously. So as a result, whatever we did earlier did not go through, right? Now let's come and check. So we have traffic growing in, but what's happening on here? And there you go. Now we have it, right? Remember, earlier we did not have it. We did not have any entry, but now you can see the entry is seen. Perfect. What do you see from here, right? It's evident that we have the employee. The role is employee, right? So, and you can see the IP address of the Windows client. Perfect. So that is good. and you can see the user type is also client. So all the clients, right, you can, if you want to see which are the clients which are available in your network, that's a good thing about Aruba, right? So gateway is like think of it as a centerpiece, right? It's like the USP of the whole solution. There's a lot of things which is happening on the gateway. So in this case, you can also see if you had wireless clients, technically the gateway can act as a wireless controller as well, right? But here we don't have any wireless, we are just doing wired. But so you can see by using the command show user, you can see the client, Windows client, showing up here on the interface. Okay, now let's try to understand. Let's look at what we intend to do. Again, let's roll back, right? There's a lot of things happening, so you always need to remember what we are doing. So let's come to routing, let's come to policy. We need to verify if our PBR is working. That's the whole task which we have, right? So we need to make sure that the traffic is actually taking the internet tunnel, right? So traffic from the branch, that is the Windows client, towards 8.8 is actually taking the internet. That's what we need to validate. So how do we validate that? We have the continuous ping running, which is good, but in fact, yeah, that's good. So we have the ping running, that's good. But what we'll do now is we'll run show data path. I think there's a command called data path session, right? I will do pipe include, we'll do 8.8.8, that's the data path, right? You can see here. So which is our client? It is 10.177. This is the, in fact this is the one, right? Cool. So what do you see from here? We see there is a entry, right? So you can see there is a next hop entry. It looks like a hexadecimal number, right? So you see the traffic going from 129 to 8 is using 4421 as the next hop. You can see it's always the same, 4421. You can see here it's always so every packet is using the same path. Great. So we understand that. Now what is this 4421? Let's try to understand. So that you can do by doing show IP next hop list. And what is a list? Remember we have that name, right? The next hop name which we gave, which is next hop branch dash internet. This is the one which we have configured on Aruba Central. Perfect. So here you can see 4421, right? And you can clearly see 4421 is what attached with the internet, right? So this is the inet. You see here, data VPNC. This is the MAC address of VPNC 1, and it is using the Verizon inet 4421. That kind of proves that traffic is correctly getting matched based on our PBR policy. It is hitting the correct next hop as we expected, and you can see the next hop priority is also 128. Remember, that's how we have configured the next hop, right? You can also run commands like so what is actually happening from a traffic perspective? What is really happening? Traffic is going like this, right? So we are here. We are generating traffic here. Traffic is coming to the gateway. From the gateway, because we have preferred the ISP, the tunnel. Which tunnel? It's going like this. The ISP tunnel, the internet tunnel. It's coming till here. Traffic is going, via the tunnel, IPsec tunnel coming here. But then on this guy, right, the traffic is then exiting out. Right now here, we don't have any PBR, so I'm assuming it will do something like a equal cost multipathing. It will either take this path or take this path, and it will come into, it will either come here and go into the internet, or it will come to ISP and go into the internet, right? That's how it is. The return traffic is also coming like this, coming back here, or it will coming back here, coming back into VPNC, and then using the tunnel and coming back like this, right? So that's the traffic flow which is happening, right? So that's the concept of full tunnel. We are not doing split tunnel, we are doing full tunnel. All the traffic from here, it is not exiting directly to the internet from the gateway, from the branch gateway. Rather, it is climbing the tunnel, going to the head end. From the head end, it is going to the internet, right? That's the traffic flow. I just wanted to give you that so that you can imagine how the traffic is flowing. Perfect. So we have validated one important thing, that the traffic is really taking the path which we desire, right? There are a few other commands we can do. Show ACL hits, I guess, right? And here you should be able to see the employee ACL. Remember, the employee, for the employee role we have created the ACL, right? And you can see it's hitting. You can refresh this and you should be able to see the updates, right, from 336 to 348 and so on. So it basically means that the traffic is correctly hitting the role. That's a good CLI to verify. What else can we check? I think there is another ACL over here, right? The full tunnel, right? The policy also is shown here, right? You can see the new hits are continuously happening 480, and if you keep on refreshing this, it will keep on showing the new hits because we are continuously doing a ping. So that also verifies that the traffic is really matching the PBR policy. We can also do some checks on the data center side, which is the VPNC one. So on the VPNC one, what we'll do is we'll do show data path. Again, the same command which we did earlier, right? Because we know that the traffic is coming to the VPNC one, right? So that's why we are checking it on the VPNC one. Again, include, and you can see the traffic coming from the client, right, towards 8.8. It is using this tunnel called tunnel 14, right? Now you want to figure out what is a tunnel. What is this tunnel 14? You can run command like show data path tunnel, right? And maybe begin. There's going to be so many tunnels, so let's begin with the SPI, right? So there you go. The tunnel 14 is this one. And what is this tunnel? You can see it is, you just by looking at the IP address you can understand, right? 10.1.51.10. So if you see here 10.1.51.10, so it's a tunnel associated with the internet, not the tunnel associated with MPLS. If it was MPLS, then it would have been 10.1.31, right? But it is 10.1.51. So it is the right tunnel in which the traffic is coming in. Perfect. Now, just to mess around with this, what we'll do is we will interchange the priority. Remember, we made internet as the priority before and MPLS is the second priority. We'll quickly go and change it and we'll see what is going to happen. So we're going to Aruba Central, right? So this is the next hop configuration. We are correctly on it, right? So we will now, we did this at the device level anyway. Okay, so we are on this one. So we'll click on this guy and here below, right, we will change, we'll interchange. So we'll make, okay, so I think you can't just edit it. We'll have to remove it and we'll have to add it, I believe. Okay, that's bad. So okay, first we'll select the MPLS guy. Can this guy pull this? Okay, so we'll select the MPLS. We'll have to delete it. There's no way to edit it. That's the problem, right? So we will delete it and we will now add. We will add the MPLS. So data 1, we will add the MPLS. Okay, but the priority here will be for MPLS, it is going to be 128 now. Okay, click on save and maybe hit the save button. And for the other guy, which is the internet guy, we are going to change it from 128 to maybe 100, right? So that's what we go. Actually, we don't technically need to we don't really need to remove the other guy. What we can do is let's keep both of them with equal priority so that we can see now that both the next hops should be getting used, right? Now let's come back. We anyway have the continuous ping running, so we can come back to branch gateway, right? Let's run the same command which we did earlier, right? It was the, I think it was the data path session, right? So you can see now one of the flow is using 4422, the other flow is using 4421, right? You can see here 4422 and the other flow is using 4421, right? Perfect. And how do we see what is 4422 and 4421? You can use this command. There you go, right? Now you can clearly see 4422 and 4421 both are getting used and the priority is 128. Perfect. So yeah, I think similarly, I mean, if you run the same command here, right, on the DC one, you will see now that it will either use tunnel 12 or tunnel 14, right? And from the top you can see tunnel 14 is the internet one, tunnel 12 is the MPLS one, right? You see it all falls correctly in place, so which means our policies are working as expected. Perfect. We can probably move this back because I think maybe for the next exercise, we might want to do it differently. So what we'll do is we'll roll it back and we'll make we'll actually switch it up. We'll make internet as we'll make internet as 100, right? So let's delete this guy. Let's change it to TC1, but let's use the internet, and let's make internet as 100 this time, right? There we go. So we tried all the three things, right? First we made internet as 128, right, which means the internet was more priority. Then we made internet and MPLS to be of equal cost, right? That way both the uplinks or both the tunnels were used equally. And last, now what we are doing is we are hitting the save. If I hit the save here, but now what we have done is we have done the opposite, which is we have made the internet as the lower priority, and we have made the MPLS as the higher priority. Okay, perfect. Okay, one last thing before we move on to the dynamic path steering, right? DPS is, right now we applied PBR policy for the whole VLAN, traffic coming from the whole VLAN. But there is also another way of doing this, that is you can apply the PBR policy for a specific role, right? Right now what we did was we had the VLAN, we had the PBR policy, right? And then we had the role as well, which was nothing but a AAA profile, right? These were all three separate entities, right? And we closely mapped the VLAN to the PBR policy. All the traffic coming on the VLAN was getting mapped to the PBR policy. Now what we want to do is we want to make a little bit of more micro segmentation, right? Which is we want to trigger this policy only for the role, right? Not for the whole VLAN, right? Because in VLAN 7 you can have an employee, you might also have a contractor coming in, right? You might have 5 other different roles, but you want to do this PBR, you want to do the policy based routing, right? Only if the source is matching, destination is matching, as well as the role is matching. Only when the role is matching we want the PBR to be activated. So we can do that, right? So let's do that. So to do that, first we'll remove the PBR which we have done based on the VLAN, right? So we will have to go to, did we do this at the device level? I think we did at the device level, right? So we'll go to security. That's something which I always forget. Did I do it at the device level or the group level? So I need to continuously remember myself. So still getting used to that part. But anyways, coming to the apply policy. So here, remember we did it here, right? So what we will do now is here for the VLAN we are going to say none, which means we are removing the mapping of VLAN and PBR. Perfect. And we will keep the AAA AAA profile, because anyone coming on the VLAN 7 we are going to define, or we are going to attach them role as employee, right? But still you might ask me the question, where are we mapping the role with the PBR? Yes, that is, we are going to do that under the roles, right? So we'll go to security, right? And you have roles here, right? And here you have the role. So we'll click on the role, and here you see there is something called policy, right? So here we're going to click the plus button and add an existing policy, yes. And here at to where we're going to, okay, instead of session I believe we'll select route here. Yes, there you go, full tunnel, right? The same PBR policy has showed up here. So I'm going to hit the save button here. Perfect. So now okay, there you go. So the policy has been configured, right? So what we did now, any traffic coming from the role employee, right, will get the PBR treatment. Perfect. We can actually, just to kind of go through the same motions, right, we can stop the continuous ping, we will disable the adapter, right, we will make sure that the IP config has gone. Yes, it has gone. We will enable the adapter, and we will make sure that the IP address is received. Okay, there you go, 10.107.1. It got the same IP address, but that's fine. So once we got the IP address, we can start the ping, the continuous ping. And this time let's go and verify what's happening, right? So if you go to branch gateway And remember what we have done over there, we have made the MPLS as the preferred path, right? MPLS tunnel as the preferred path, so it should technically use this 4422 now, right? Let's make sure if that is happening. Right, there you go. So you can see traffic coming from this to 8.8 is using 4422, right? Everywhere it is 4422. Perfect. So traffic coming from our role, right, is getting matched now. Not all the traffic from VLAN 7, though right now we just have only one client in VLAN 7, that's true. But what we have now done is we have made the policy work based on the role and not the whole of VLAN, right? So yeah, that kind of concludes everything we wanted to do with PBR, right? So the next one is we will now explore the the dynamic path steering, right? So once okay, I just realized this video has become quite lengthy already, so we'll probably wind up this particular session with PBR, but at the same time we will come back and we will do the DPS in the next video. I don't want a particular video to be way too lengthy so that you lose out on the content, right? Yeah, so just to recap, what did we do with the PBR? Again, PBR is one of the most important policies, so it's very important to get our concepts right here, right? So we had a very interesting use case where we created a dedicated PBR policy. We defined what are the various traffic matching classes or classifiers, right? So we basically match the traffic coming from VLAN 5678 to the traffic either going to the VPNC's data centers, or traffic going to the internet, or traffic between the branch subnets, right? So we defined the PBR policy and the various next stops the PBR policy will need to use. Then once you created the PBR policy, all we had to do was apply the PBR policy. We applied it once for the whole of VLAN. Then we also demonstrated that you can also apply it for a particular role as well. So we applied it for the employee role, right? And then we obviously validated that the PBR policy was working. So I'll go ahead and delete the PBR policy from the role, and I will wind up this lab. I'll catch you on the next one where we will talk about the dynamic path steering policy and its verification. Okay, thanks a lot for watching. Have a good one. Bye.